Okay. So I hope everyone is refreshed from the break we had. And we're gonna continue with session 2, that is about climate change impacts on maritime archaeological sites. Jesus will be our chair for the session, so I'll just hand it to you, Jesus.
Hi, good day to everyone. Good morning here from Colombia. It's kind of early, but I'm really happy to be here with you in this fantastic space. I want to send a special thanks, of course, to Caterina Belenza and to Victoria Weiss for organizing this fantastic place, this space for all this devotion and discussion around this like hot topic that is now currently in a lot of sessions, in a lot of congress, in a lot of events around the world. And I'm really happy that now we can like connect it with this maritime archaeology, underwater archaeology, and in general with underwater cultural heritage and maritime cultural heritage, of course. So right now, I'm going to present, like Katarina say, this second session related with climate change impacts on maritime archaeological sites. And in first place, I would like to introduce this fantastic investigator, this fantastic archaeologist that we already know how he works because he came to Colombia a couple of times, and now we can consider, of course, a huge friends from Colombian archaeologists. So I'm really happy to introduce José Manuel Matés Luque from the University of the Basque Country, and I'm not going to say it in Spanish because I think that the third word I can pronounce it well, and he's going to present us this high record watercraft you people wouldn't believe. All of those moments will be lost in time due to sea level rise in the Basque Country in Spain. So, Jose, the floor is yours. You have 15 minutes.
Okay, thank you very much. Can you hear me?
We can hear you
Yes.
perfect.
Okay. Thank you for organizing this event and accepting my paper. I suppose that many of you will know that this quote is from Blade Runner, when the replicant was saying that to Harrison Ford. So I also would like to say thank you to all those people involved, all the institutions, particularly those who provided funding, so I could be able today to present my research to you. So that's the Basque Country, the Regional Council from Biscay, and the INA from Texas. And everybody else were supporting me with their time and effort, so I would like to thank them. Well, for those who are not familiar, this is the Basque Country. It's on the north coast of Spain. There are several estuaries that I surveyed, and I'm going to concentrate particularly on those two. And I will also say particularly in this one, the Lear Divide in Lake Aitio, for those of you who are familiar with them. We should say that climate change is not new to human beings. We should remember that somehow underwater archaeology started when in Switzerland, the water level of several lakes were reduced due to droughts, and these pile dwellings appear. And that also happened recently across Europe for the last few years. This is from Spain, different places, also from Italy, where the level of the rivers have come down, and there are several remains exposed. This was a few days ago in the Basque Country in Pasaia, very close to San Sebastian. This is a square. You can see that because of
Sorry, Jose, I'm really sorry to interrupt you. I don't know if you are sharing your PowerPoint presentation.
All right.
Because
Okay.
right
So, oh
now,
yeah, sorry.
don't worry, don't worry.
Yeah. My mistake.
Right
My
now.
mistake. My
No,
mistake.
it's
Apologies.
yeah. I can see it. Terrific. Thank you so much.
It's just that I had a problem earlier with the computer. It switches off, and I was a little bit okay. So I was saying, yeah, that I would like to thank all those people, the institutions. This is the area in the Basque Country where I survey, and I'm going to concentrate on these two, particularly this one, the Caitio. Now, we should say that climate change is not new. Underwater archaeology somehow started in the Swiss Lake when the water falls down and those pile dwellings started to appear. And for the last couple of years, 3 years, there have been several droughts in Spain and also across Europe. So a few days ago, this is a place close to San Sebastian. This is one of the main square for the village, and this is how it should be. But you can see that because of the spring tides, so water is certainly a threat to everybody. Now, I'm a freelance archaeologist, and I have the chance a few years ago to do the watching brief of this breakwater that joins a beach in Lecatio to an island nearby where there's also sorry, archaeological resort. There are several excavations. So this is how, because of the currents and all the time and no maintenance being done, how the breakwater, which is from the mid-18th century onward, was, and this is how it is now after the repairs that you can see at the bottom of the screen. This is the landscape. This is the breakwater at high tide. It was built to protect the harbor from all the sediment coming down from the river, but there's also several shipyards that obviously if the sea level rises too much, all this area, the beaches, this shipyard, which is now being restored, will eventually be affected. Now, in my research for the last, I would say 7-8 years, I've been recording different cultural remains in the intertidal zones. There's here a few pictures about some of the remains, depending on the area, the Bilbao area, or more rural ones like these breakwaters, piers, etc. Many of those, because of the sediment, are covered. So I'm sure there are areas where the estuaries are covering remains that we cannot see right now. A few years ago, also this canal was open, partly because of the threat of the sea level rise. So it was the idea of providing with extra space for the water to come out, particularly from the river, avoiding floodings. But in the watching brief, we found out the remains of an old shipyard. You can see here some of the timbers related to that shipyard. And there's also an engraving. This is more or less the area or the shipyard. So it's also telling us how the old landscape looked like. This is some pictures of how the estuaries and the shipyards in the Bilbao area looked like in the past. So I guess we can use that to get ideas about cultural places that need to be done. This is how this canal was opened, and also with some still cultural remains there. This barge is an iron one, and when the height is very high, when the tide is very high, you cannot see that remains. So there are some wrecks on those estuaries that I basically survey, and I concentrated on a few ones I'm going to mention. For instance, like this one. This is in the KTO. We were recording the different excuse me, remains. This is a quite modern pleasure boat, but you can see all the debris on top and how the tide is also affecting. So when the water is high, you cannot see those remains. Obviously, all the sediments will add a layer after layer, year after year, and those remains will disappear. More recording of bigger and more interesting structures where you can see really nice features for understanding about shipbuilding techniques in timber, because now basically for the last 30 years or so in the Basque Country, basically all ships are built in iron. And here you can see a very interesting boat with the dates. I took a picture in 2008, and you can see how has changed within 10 years. All the side has collapsed, disappeared due to not only the river and the natural courses, also for human activities. They were repairing a tide mile, which is just nearby here. The caterpillar have to make a space for itself, so it destroyed part of the boat. You can see how this very nice boat has changed for the last basically 10 years. Anyway, if we pay attention to when recording to those features, to those timbers, we can find some very interesting features. And for those of you familiar with the Ibero-Atlantic building tradition, I would say that this is the 20th century evolution of a 16th century technique. So certainly those remains, even if they are quite modern, can tell us a lot about shipbuilding activities and evolution throughout the century. Now, more wrecks on that estuary. You can see a picture from the 70s, 80s, how the vessel now look like. We did a few excavations there, also in nearby areas. And this is another one in Ondarroa. You can see how this boat, this is very basically at the end, at the mouth of the estuary, and the water covers constantly. We were just basically cleaning the last bit and get out of the place because of the tide. And this is one of the last boat I recorded. It all started with this small timber. I thought it was part of a boat, and obviously after we did a bit of excavation, we could clearly see that it was a boat. The funny thing about this is that it's very close to this cliff. It's nearly 2 meters in height. You can see this is now at low tide, but the tide is always pushing this cliff backwards. So eventually one day, the nature will reclaim all this area, and this boat, which is now covered completely with the sand, will disappear. Again, we can see very nice, interesting features in these boats. This is the full size of the boat. We did a radiocarbon date, and it was built in the late 19th century, early 20th century, abandoned in the mid-50s, 1950s or so. So now the Basque government has been working on how climate change is going to affect the population, but it's paying attention on the economical aspect about how it will affect railways, roads, how it will affect people, or the health of the people, but it's not paying attention to the cultural issues, even though there are areas. This is the area where most of the wrecks, the timber wrecks I show you are abandoned, will be completely covered by the sea when the sea rises. So there are many estuaries. I would say all estuaries in the Basque Country will be affected, and we know very little about what's going on them in terms of archaeological heritage. So you can see here how the different scenarios that they have foreseen in 100 years time, 200 years time, 500 years time, etc. So it will be a place where the water is going to be permanently there. So the access to that cultural heritage will be quite limited. Just for you to see the different depths in that estuary. So certainly it's going to be a challenge. It's a challenge nowadays being in the intertidal zone. So imagine what's going to be when the water covers this area completely. So very quickly, I will go into that. So just to finish it off, I would like to say that obviously we know that climate change will affect everybody, people, landscapes, animal and plants, but also the cultural resources will suffer because of the water temperature, salinity, acidity, the intertidal zones because of the schedule about 6 hours underwater, 6 hours at the with no water at all. It's also suffering, I would say, more than a constant layer of water. So we need to pay attention to all the different cultural items that are available there, and perhaps we could use those areas, those items, those cultural items, like places where we all researchers, biologists, geologists, people who manage the sea and the coastal can work together to understand not only how climate change will affect us as human beings, but also how it will affect our cultural remains, because that's part of what we have done for the last 200 years, 500 years, 1,000 years in the past, and what we have are been doing now to those cultural areas. So I think it's the moment, and this is something I would like to, once I finish a few things within my research, I would like to propose to the different agencies within the Basque Country and the regional councils about cultural items that we have in the intertidal and the coastal areas are also part of the climate change threat, and you should not overlook them. It's nice that you pay attention to the roads and health, the flora and the fauna, but we or you shouldn't forget that cultural remains are there. It's part of ourselves, and we should look after them as well.
Well,
So,
José
thank you very
Manuel,
much.
no, thanks to you. It was a fantastic, a really great presentation, of course. We can see some claps on the comments. We are familiar with your work since a couple of months, a couple of years, and I'm really happy to see how is everything evolving, like all the alternatives and paths you're taking to try to do something, right, with something that usually can be ignored by some government agencies, by some institutional perspective that they don't consider that it's important. I'm going to open the floor for some questions. We have 5 minutes to do that. But if if meanwhile everyone asks, I would like to ask small little things, because we see how these all these water level variations and all these impacts that you're recognizing with this interdisciplinary approach to try to understand how it impacts cultural heritage. But of course, we are from industrial perspective and industrial activities, how there are some still remains. And I would like to ask you, because you are recording and communicating all this through the last years, how which in your concept, from your notion, which alternative you consider that can be useful for monitoring this change through the time, because we know that photogrammetry now can be used to try to understand this year by year. But how I think that when we are trying to understand these climate change impacts, we are also trying to know how to mitigate, how to monitor, and how to make some counter impact on this. And of course, this question will be useful for Spain, from Colombia, for Latin America, and across Europe and the world. So I would like to hear your.
Okay, so when I started this research, I was involved with the intertidal areas because I was familiar with the area, and I saw there are so many different cultural remains, and nobody was paying attention to that, because for many they are so new that it's rubbish. Oh yeah, we know about that boat, or it was my grandfather's or my uncle's boat, and it's rubbish. So who cares? Unless you got a 500 years old boat, or there's something on the water, it seems to be that that's not archaeology, and that's not the case. All those remain, even from the industrial era, are part of what we did and what we are somehow. So that's why I started my PhD on recording that area, and I focused it on the wrecks because of what I mentioned earlier about all those features that it's also some related to what Katerina was saying, that the European community was given money to the fishing fleet to destroy the old wooden boats, and to manage the fishing fleet, etc. That's why now basically we haven't got any timber remains for recent boats. So I thought it was like a reservoir, and trying to understand those. So first is recording, then is trying to have as much information as possible about the history of that cultural remain and the landscape, or the seascape, or the intertidal escape, whatever we want to call it. And then That's why we cannot be there every single day, but there are other researchers who are dealing with the same seascape and landscape, biologists, because for instance, let me go back. The environmental agency didn't allow me to get into this boat. There's a very interesting boat here. Didn't allow me because all this seagrass is an endangered species, and they say, oh no, you cannot go there. Okay, fine, I cannot go there, but since you are controlling and monitoring this area, could you please pay attention to this boat? Let's go once together. I will record that, and you could, at the same time you are monitoring the seagrass, you could say, oh, now the stern portion is gone, or this frame has gone. So it's also, using the resources from different aspects to gather more information. Similarly, if I'm recording this boat, if I'm monitoring this boat, I could pay attention on how this coastal has been eroded, or if there's new flora or fauna that we haven't seen earlier that is coming in. And obviously that will tell us, oh, there's this new fish. It was no longer available because it's let's say, a tropical fish, and now we can see that. So certainly, the sea level and the water temperature is affecting all this area, etc., etc. So even if we have to put some sort of test, like probes to have water temperature from a remote position, we could gather together all that information, because that will also affect the remains for the wrecks. If there's more water temperature or the salinity, and this area is up and down because of the tide, it will also accelerate the rate of decay. So I would say that's, we have to work together and not seeing our area of research as a narrow-minded and say, oh, I'm only interested in wrecks. I don't care about what's happening to the coastal, to the flora or the fauna, because it's a circle that is connected, constantly.
Terrific, Jose Manuel. Thank you so much for your answer. Of course, we are seeing in every of these cases which are the connection between not only between archaeology and biology, but other science which will help us to monitoring. And it is happening in the sea, in the rivers, in the reservoirs, in the lakes. So it's really great. How can we understand this not only from the site formation process, but also from the future perspective of how can we understand this?
Exactly.
So thank you so much. I would like to ask you, because we have to go to the next session, to put some email or some contact in the chat, because I don't know if there is any other question, so maybe they can directly ask it to you.
Yeah, sure.
So I'm going to introduce the next presentation. Thank you so much, Jose Manuel, once again for your great presentation. I'm sorry if I mispronounce your name, Sirine, Saad, El-Dine, Ghiye. From the Ulster University, with the presentation entitled Potential Climate Change Threats to Maritime Archaeological Resources. So, Sirine, the floor is yours. You have 15 minutes.
Yeah, thank you for having me. I'm going to present, I'm sorry, I'm not sharing my screen with you.
No, we not see it right now.
Okay. All right, great. Can you see it now? Yeah, so I'm going to present the potential climate change threat to underwater resources. The presentation is going to present the main impact on marine cultural heritage due to climate change. The presentation is going step by step, first by identifying what is a climate and what is climate change mean, to understand the evidence of the climate change or the main factor which led to change the climate over the last decades. A small case study, an area called Chikka from North Lebanon. The main is to detect the changes of sea surface temperature during the last 20 years in this area, to conclude the main impact on marine culture heritage, underwater site and culture and coastal sites. So what is a climate? Climate can be defined in two levels. The local climate, which is the climate of a special area or country, and the global climate is the global ODRs. As we see, as protection agent, the climate is a connected system of the earth from atmosphere, land, oceans, and all people do too. And they are responsible of ecosystem and life on the earth. And the changes in one of the property of a climate lead to change the climate, the global climate. So why climate change over the last years? The report from Intergovernmental Panel on Climate Change in 2014-2015 described in direct way the main reason, or the one reason which led to change the climate, which is the anthropogenic activity or human-made. As we see today, the infringement on the coastline, the emitting of toxic gas from the industries located on the coastal region, and the growth of population. Growth of population is the main reason, because more population mean more services, need of food, and water consumption. As we see from the graph from World Bank in 2015, which describe only the growth of population in the Mediterranean region. The population increase in 1960, it was 259 million, increased to 537 million in 2015, expected to be 670 in 2025, sorry. And more than 60% of population are based on and located on the coastal region because of quality of life offered in this region. So evidence climate change, it's the increasing of carbon dioxide in the atmosphere, which lead to increase the temperature of the air. And because the global is a connected system, so increasing of temperature of the air change the global climate. And this evidence take a long time to recognize by scientists, and they compiled that it was at the beginning of 19th century, and measuring the changes of temperature. Change of temperature need a lot of measurements and data gathered from different tools, special from satellite imagery. So what happened after this? The increasing of temperature of the air increased the sea surface temperature and the land temperature. So then the ice will melt, and the ice will melt, and adding more water in the basin of seas and oceans lead to change the level of the seas. To pass to our case study, as we see here, the map of Lebanon, the coastline facing the Mediterranean region, and our case study is representing in the yellow circle, Shukka, located in the north of Lebanon. The main is to detect the changes of sea surface temperature in the last of 20 years in this area. And why here, sorry, image from Landsat 8 natural band composition to look some detail of this area with some landmark. As we see here, the Tel Mirhan is an archaeological site based on the coast, is under study and excavation. In addition, the current harbor of this area, and two cement factories in this area. In this case, the area was covered by olive trees and salt marshes on the coastline, but this is changed after the construction of first cement factory, the National Cement Factory in 1931, followed by Holcim factory after 2 decades. The coastline changed after the construction of the harbor. In addition, this area, the land of this area is have a special morphology and topography, because the land is a cliff gradually fall into the sea. The area is also very known in Lebanon, and since the antiquity, it's well mentioned in royal resources, royal letters, and ancient resources. And Shikka have two potential harbor from north and the south at the headland of the Shikka, as we see here in the map. And this area is occupied since the Bronze Age. That depends on the archaeological excavation and the survey, archaeology survey in this area. So the methodology of studying this area depend on the use of satellite imagery and geographic information system. The data gathered are from Lat 7 and 8 with 20 years difference, and taking into consideration the same season, summer and winter. And why I'm using this technique, because the sea surface temperature is the first variable of ocean to be studied by satellite imagery through the infrared and microwave radiometer on polar orbiting satellites, and from the infrared radiometer from geostationary spacecraft. The sensor deployed on the satellite imagery are operational land imager and the thermal infrared sensor instrument, allow to assess the water parameter efficiently, and through them we can measure the land temperature in two thermal band with the new technology, apply quantum physics to detect heat. So to calculate the sea surface temperature, it's about like equation based standard equation used on using by raster calculator on QGIS. There are several steps to do this. First, by calculating the top of the atmosphere radiance, which is the which is the image captured by thermal sensor. Then we calculate the atmosphere reflectance, which provide the ratio of radiation reflected to the incident solar radiation on a given surface. The result depends on the property of the material itself. This in order to use them to calculate the brightness temperature, which is the measurement of the radiance on the microwave radiation traveling upward from the top of the atmosphere to the satellite. Finally, calculating the emissivity for each pixel, which is the emitting energy from material on land as thermal radiation, in order to convert them into the sea surface temperature or land temperature. The results obtained are thermal map, as we see here, to map during the summer. I choose to collect the temperature over the coastline to see how the temperature change near the cement factory and far from the coastline. As we see here, to map during the summer from Landsat 8, during the year of 1999, the temperature was 24 to 25. And today in 2021, the temperature increased to be 28 to 29 along the coastline and near from the cement factory. The same case during the winter. The temperature in 2000 was about 14, but today it's 16 degrees. So how the increasing of sea surface temperature impact on maritime archaeology or underwater sites, which they are already underwater. To pass to on the impact on coastal sites. As the Intergovernmental Panel on Climate Change, in their report, they mentioned that the sea level rise as 1 meter, which means 4 by 15 millimeter per year. And sea level rise increase the severity of extreme ocean events as the typhoon and the storm, which affecting both coastal and nearshore sites. The effect of sea level rise lead to flooding, especially during the heavy rainfall, and not only it impact the cultural heritage, the marine cultural heritage, but also it impact the maritime boundary, which become less well defined, and the high frequency of such events increase the erosion of the coastline. Example here, the case study of Shikka, as we see the coastline was in blue, the shoreline of 1962. So because of the erosion with 79,000 meter cube, as we see in the red area, this all because of the frequent erosion of the coastline, the shoreline and the morphology of this shape of the morphology change in 2007 only in this area. So and as the UNESCO, it put dozens of World Heritage in the basin of the Mediterranean. They are under threats, and maybe they will destroy because of rising of 2.2 meter of sea level rise, and that by the end of 2100, it's just a prediction, but it put how the the impact is very high on the coastal regions. To pass to the impact on underwater sites, also from the shipwreck and the submerged prehistoric are also susceptible by the erosion because of tidal currents and wave action. In addition, the submerged sites will affect by the sea level rise because adding more water on the site mean adding more pressure, and maybe it's more than they can withstand. And it also affect the time for diver, how much can the diver can remain underwater, and also the increasing of temperature not only on the surface but also the deep water increase from 0.6 to 2 degrees, and that after the report from the Intergovernmental Panel on Climate Change in their report in 2019. And increasing of temperature, it increase and double the corrosion of the underwater metal. In addition, there are changes of marine environment and chemical, physical, and biological levels. An experience made in Morocco on the experience on wooden pine block submerged for 1 year in the Atlantic estuarine on Morocco, showing how there's presence of new bacteria and worm at the Teredona Valley, that due to warmer water. In addition, the acidity of the ocean and the seas increase, as we see from the graph provide the pH of water, the global mean seawater pH provided by Copernicus Marine Environment Monitoring Services. The pH decrease, that means the acidity of seas and the ocean increase. So to conclude all of this, there is a direct effect of climate change on marine cultural heritage, underwater sites, and the coastal sites. And we can conclude that the maritime archaeology and the climate change are connected and very connected, because it become a key to study the past climate and the human past adaptation with the climate change, where maritime and the coastal site illustrate the environmental changes. And several studies which focus on the human interaction and as the migration and the uses of aquatic environment can predict or may inform us what can happen in the future. So it's important to involve the cultural heritage in climate action, because heritage include the identity of people, and they want to pass this heritage for the future generation. And this heritage is under risk because of climate change. Thank you so much.
Well, Sirine, thank you so much for your fantastic presentation. Of course, I'm really happy how we can see these different initiatives around the world, but mainly how archaeology have something to say about it, right? Of course, not alone, working with a lot of disciplines, a lot of knowledge areas, but I also am very grateful for your presentation, because You say at the beginning all this full context of climate change, because sometimes we take it for granted that everyone knows what it is, how it works, how it's impacting this all this context, and of course maybe on the public we have some persons that are not full familiar with it. So I'm really thankful for all the concept and all the interpretation that we can apply now in your geographical interest area of investigation for a study. I would like to ask from everyone of the public, you can open your mic to your microphone to ask some question, or maybe you can ask it on the chat. And I can read it, of course, with no problem. Meanwhile, with these 5 minutes of questions, I would like, meanwhile, to ask um, how you when you were presenting all these Landsat images and all this GIS interpretation. I'm reading now that there is some question on the chat, so I will open the floor because I'm speaking a lot. So of course, anyone else who wants to ask something, if we have more time, I'm going to ask it. But please go, Victoria.
Yeah, I'm sorry, no, but you can continue if you want.
Yeah. No, it's a small question actually. It's related with the seasons, because we don't have this happening in Colombia. We don't deal with this. So I would like to ask you the implications, the considerations, the topics that we have to consider, and you consider usually when you analyze these different images from different years, from different months, from different weeks related with season. Which are the implications to understand from a maritime archaeology perspective, in trying to understand the climate change impacts and consider this variable, this factor, which is basic thing for you, but not for all the world, related with the seasons.
Actually, using this methodology, I already learned during my courses in the university, and my aim is to present a small case study how the temperature change in this small area, only because of the growth of population in this area and the construction of cement factory without like any future planning for this cement factory in one small area. So if we think about it, it's only a small area. The temperature change a lot, like average of 1 degree maybe. To think about the global what happened, globally what happened in on the Earth. So this case study is just to illustrate and like as a reference for other what can happen in the globally, and the interpretation, the impact on the coastal side and on the water sites. I followed many articles which like describe and just put a hypothesis about the increasing of sea level rise and the increasing of temperature, not only for the underwater side, but also the archaeological site on land. So hope I answered the question.
Victoria, go ahead.
Okay, so I'm going to make a short question. So I would like to know what kind of characteristics you have the image you're using to be able to do this analysis about the temperature. So is there any the satellite imaging, do it they need to have a special feature or something, or you can use any?
It's only the Landsat 7 and 8, because they did a sensor on the both satellites. So from both type of this satellite imagery 7 and 8, we can measure the temperature. And I want to mention that calculating of thermal and radiance and all of stuff that I mentioned before, the result of each calculation, it's also a map, but it gives us like it's also depend on the pixel and the and the type of map that produce. So all of them are from lesson 7 and 8 because there's a thermal sensor deployed on the on both Landsat. So for this why I use only Landsat, not other type of satellite.
Thank you.
So I answered the question.
Thank you so much. We have like a couple of seconds more for some questions that Lucy Seaman, I don't know how to pronounce it, I'm really sorry, who said, well done, Sirine, could you walk us through the impact of the Cheka coastline?
Thank you.
Sorry, I don't know if you can hear me right now. You can hear me well? I cannot see it. Maybe I'm having some connectivity problems. I can see.
Yeah, I can hear you, but it says it's a bit slow. So.
Okay, I'm going to turn off my camera. Meanwhile, I don't know if you can see me and hear me better. Well, this happened on this virtual media, so it's kind of a mess sometimes. But Sirine, I don't know if you hear me. The last question from Lucy Seaman, who said, "Well done, Sirine. Could you walk us through the impact of the Cheka coastline?" It's on the chat if you can read it, of course.
Yeah, as I mentioned before, that the coastline changed because of construction of the harbor and the infringement on the sea because of construction of the beach and something like this. And also for the Tel Mirhan, the Tel is it's about clay. All the layer of this tell is like very clay and sandy, and the walls that discovered from Bronze Age are also sandy stone. So they are impacted by the flooding in this area because next to the tell there is a river, and sometimes the river is flowed, and so the erosion of the sands and the wall are increased. Another the color of the water there is like more oily because of the cement factory that. So yeah, there is not like a focus study on this area about how climate affect this area especially, but this from my my vision when I make a small survey in this area.
Terrific, Sirine. Thank you so much. We have to go
you.
to the next presentation, and I would like to introduce Deanna Groom from Bangor University, who is going to present us the historic shipwrecks and the impacts of climate change, the Welsh experience. So, Deanna, the floor is yours, of course.
Yeah, good morning. Oh, yes, you can see my screen. Thank goodness the technology works. But anyway, yes, good morning. My name is Deanna Groom. I'm undertaking a program of research associated with themes of historic shipwrecks and the impacts of climate change at the School of Ocean Sciences at Bangor University. And this is in North Wales. And Wales is one of the devolved administrations or government administrations that make up the United Kingdom. So yes, we are next to England, Scotland, and Northern Ireland. So the importance, just to give you a bit of context for the research. Oh, I'm going to have to move. Yeah, so it did turn over, that's good. So yes, to give you a bit of context to what I'm doing, the Welsh government produced its first national marine plan, so this is marine development control in 2019. It contains 13 top level objectives, 7 and 8 really relate to the historic environment and supporting climate change adaptation and mitigation. And this was followed in February 2020 by the Welsh Historical Environment sector itself producing a plan which identified research priorities for the whole of listed buildings, for archaeological sites, and for the marine side as well. And those two priorities in there were to carry out spatial mapping for heritage sites at risk, and also to start to look at some of the impacts of ocean acidification and changing marine species on wrecks in the marine environment. So, I mean, I'm so glad to be here today. I remember with lots of listening to the talks already, lots of like-minded people coming together and really beginning to try and think about and address some of the problems that we're all facing. And I think probably maritime archaeologists, we focused a lot on the in time of site formation. So it's the chemical, physical, biological processes. But what I think we're all beginning to realize is that the things that we've given the oceanic climate change, even the properties of seawater are now beginning to change. So all that sort of things that we've relied on to preserve sites in situ are changing relentlessly as well. And just to give you a bit of an idea of what the Welsh resource is, offshore certainly, we have nearly 1,000 shipwrecks, and they represent certainly the underwater culture heritage of about 17 nations as well. So we're not just thinking of protecting the Welsh here, we're thinking more about the bigger picture of looking at other countries' underwater cultural heritage. So just really my starting point was this was some work that was done by it's a marine climate change impact partnership. They produced a matrix back in 2018, I think it was, where they kind of they tried to put down what they knew was already happening. And then I kind of tried to add to that this matrix. I know it's very text heavy, I do apologize. What could be happening to the intertidal and submerged heritage assets that personally come under the topic of this my research PhD. And for example, we're looking at as our oceans absorb more carbon dioxide, they're becoming less alkaline, and that's the process called ocean acidification. And this is likely to impact on marine species that form protective coatings on the surface of shipwrecks. And then for metal wrecks such as iron and steel used in shipbuilding, seawater acts as an electrolyte. So immersion triggers complex anodic and cathodic reactions between metals based on different electrode potentials. So, if it's generally if the environment, the electrolyte is more acid, those corrosion rates increase. So I think the unknown is the threshold. Will oceanographic climate change begin to trigger a cascade of really significant destructive impacts? And part of the research is developing this matrix further. And they're very text heavy, so I won't show them to you. This is probably as light as it gets. But really to put inputs such as ocean acidification, increased more severe storms, and ocean warming into matrices which actually kind of try and tease out across those physical, chemical, and biological processes, what impacts that really will have. I was very much aware when I started this that it is a global issue, and we're all trying to, we're all struggling, beginning to try to get our brains around what is really happening. So one of the things we did in September 2021 was do an online practitioners survey, and I'm so grateful to all of you that responded to this. It has been really, really helpful. So just put the key themes and the key priorities, what we're trying to address with the questions that are included in the survey and how it was distributed. And the little key that you see there was just keep an eye on the light blue, because these are where the extremely important and it's a key to where the most people, they showed the bigger that kind of light blue area is where the consensus was. Most people thought the same thing. So just to show you I'm not show you all the survey, but I'll just look at a couple of things, or just show where people responded from. So it was a worldwide response. So huge thank you for everyone who participated in that. Just to look at question 8, for example, is one of the ones I look at. It was asking about what they felt was the most what were the most important factors to understand the impacts of climate change. And so most people, the consensus, you can see, they came up on more frequent and severe storms, And then it's this question of understanding the interactions with these site processes. For example, there was the survey facilitated, a large area of people put comments. Some of these some was really excellent. They kind of prompted, if sea level rise will have a massive impact, but if you combine that with increased storminess, that's even more of an issue. And also they picked out, things like offshore development control, if managed correctly, if you're going for more marine energy to counter to come off fossil fuels, the use of fossil fuels. But if it's managed correctly, it has can have a positive impact, where through discovery, designations, and awareness raising, you are actually bringing more sites into the public domain. So just look at question 9 again. This is what people thought were most important, regarding mitigation. And really, it was to, you see the consensus there were about encouraging the development of national policies, ensuring that underwater cultural heritage is fully included in the research agendas, and understanding and establishing some underwater investigation standards. So I think we promise there's a commonality in how we kind of record sites, but maybe there are more things we could think about doing. I think José mentioned them, that what we do can contribute to those bigger, wider agendas by looking at marine species, and there's other kind of factors as well. So there were some good comments there, even the honesty about standing up and saying, we do not understand the impacts of climate change and underwater heritage. And I think this is where, some ways, we're kind of at a baseline, but we're having to rapidly move forward with this. And just to show you some of the things that the participants were asked was to suggest sites that had the potential to act as climate change indicator X. So this is where sites have possibly a particular climate change threat that's been identified, or based on a pool and a sort of a good baseline data from which to monitor in the future. And I think it's, and there were 6 that were suggested, and the more work has been done on this. I think it's fairly easy. It's not a far-fetched, or it's only a small step to sort of basically to try and start putting together a network of these sites, which can start really contributing knowledge, sharing data, and best practice, which is the other important thing. So just to look at some of the work that I actually did. Now, I've kind of given you a bit of context there, but just to say the petitioners, this survey really helped to guide and sort of helped focus 2 aspects, which were the generation of data products and into the field work that was necessary. So just to look at the 3 data products, really. The first was trying to develop, identify areas where with the most archaeological potential, and so this was a combination of density count, seabed sediment type, and then max tidal stream. So you're looking for areas of seabed where you have the it's a deposition is preferred, is the option that happens. And to these, added some other climate change factors, and what projections are for the future. So this is like a sampling grid. It's laid on all those different data sets that come in, points, grids, polygonized raster sets. It's developing a way of sampling that kind of pulls it all together into attributes that you really want to have readily available. The other was looking at a storm wave base, and this is the concept about this is where it's with the maximum depth that when a wave's passing cause significant water motion, and it basically starts, and when it touches bottom, it starts to disturb the sediment. And we have around Wales, we're very lucky to have a network of 5 semi-permanent and 3 temporary wave measuring stations. We can provide a useful data set. And so linear wave theory, it's a bit tough for an archaeologist, but we did have a go at it, and it's the mathematical method by where you can calculate the spatial areas based on the storm data and the wave data and so on. So what we have from sort of generating these GIS sets, we've got a rough averages from looking at some of the storm data that's been gathered by the boys, and it's usually between, for Wales, it's between 15 and 30 meters that's your storm wave deaths. And we have nearly 400 sites that fall within that. So when we get really bad weather, there are 400 sites around the Welsh coast that are probably experiencing some form of sediment movement now, and in the future that will be probably increase with more severe storms. You can also do some sort of quite fun things with this data set. You can, where you have a maximum, you look at where a survey has been undertaken in the past. So you can look at densities of wrecks, and you can highlight particular areas, the areas in red that you see there. You can also kind of flag areas that have got the longest offshore fetch, over 1,000 kilometers, and that's the little map in blue on the left. And part of what we're starting to do is look at transects. Can we look at sites that are out with the storm wave base through a transect to sites that are within it, to kind of see to actually trying to get some idea of what the difference is between sites that are not likely to be affected and are affected. A bit complicated, but that's kind of where we're at the present time. So identifying sites at risk in the Insider was probably the focus of the third dataset GIS product, and essentially it's to gain a better understanding of what beaches do and in response to wave energy. And I'm probably speaking to people who know a lot more about this than probably I don't even know. But during a storm, waves access the sand stored high up on the beach and on the beach, and when it's calmer, they move that. During the storm, they move that sediment offshore, and during calmer periods, they kind of pile the sediment back up onto the beach. And the profile can vary as a time of function of year as well as time since a storm. And you have these basically you have what becomes like a winter or a summer profile for the beach. And so I know it's quite difficult to make GIS plots that are very sexy and interesting, so I do apologize, but that gives you some idea of what kind of the depth of detail that's included against the attributes of each of these digitized area. It includes beach condition, prevailing weather direction, wreck counts, of course, and sediment type, etc., to try and build a kind of a ready access data point where you can kind of pull all this data comes out. And there are Wales does have environmental data sets which can be used, some produced by the offshore energy industry. The top left there, this is a plot of which beach, some of the south coast of Wales, which beaches receive the most highest wave energy. And you can see that's mouth of Milford Haven. And for our research, for my research, it was kind of Carmarthen Bay and Rossili Bay on the right of that picture. So from the wave buoys, you can get things like sea temperature, dominant wave directions. We have a Welsh Coastal Monitoring Centre, which is now, since 2019, is beginning to systematically, to a national standard, collect beach profiling data. And you can do the standard things, is taking beach samples and running those through the sediment sieves and things to get an idea of what their composition is. But when you're looking at future projections, this is some work that was done by the National Oceanographic Centre at Liverpool. And you see, basically what it's showing is kind of from year 2018. These were the storms we're experiencing in blue. By 2100, they are much more spiky in pink. But I think in terms of this summer and winter profile, that's kind of summer calm period is going to get much shorter. So our wrecks on the beach are going to be spending a lot more in their uncovered state, a lot more exposed. And obviously that's open to, physical abrasion, rates of degradation would increase, etc., etc. And just to show you, Carmarthen Bay was one of the sites. I'd say Carmarthen Bay, just show you one of the sites from Carmarthen Bay. This is a wreck, large timber wreck. It's believed to be the Victoria, which was went ashore in 1877. It's an Italian bark. And you can see the difference. You have the winter profile on the top left there. You can see much more of the centre is exposed, the keelson and the first line of buttocks or frames, and also the top right there, that whole run of outer planking is much more exposed. But in summer, it backfills, the sediment moves around inside the wreck, and a lot less is exposed. And we've also been using things, just other basic archaeological tricks like comparable views, look at the, the sediment cover, finding the same frame or same feature on the wreck to, take photos and compare to archive imagery. And also by using photogrammetry, I should say, it's this amazing technique now, and we have it's not anything high tech really. These are quite basic, inexpensive waterproof cameras. You can start to, pull together these photogrammic models. You can use things like cloud compare to look at where the sediment is building up and where it's lower. So these are just to give you some idea of what that kind of analysis is showing for. I think 17 sites now have been done in this kind of way. And once we can locate them on the beach profile, it's quite subtle, but this wreck, the Victoria, if it is the Victoria, is kind of located on a beach that don't seem to donate. It's the edge of where it donates and it draws down and rebuilds. So this would explain some of what you're seeing between the winter and summer profiles. So just really to find out, the task we've been given was to look at marine species. So what part of the project has also been to develop a marine ecology species database. There were 3 sites within the National Monuments Around which had ecological surveys, and the Marine Conservation Society very kindly donated data for another 50 wreck sites around the Welsh coast. So this is quite a substantial data set now. It's 516 species records linked to 50 sites. And from this and from doing a lot of online searching, and we've been able to kind of identify, look at things like climate change impacts, like increased salinity. How do these species respond to temperature, increased wave exposure, submergence, and also how do they compete with invasive species? And what we've come up with, and a lot more consultation on this, because I'm sure the marine ecologists will want to be very much a part of the final production of this list. But we know that we have, these are the sites in Wales that have invasive species on them. There are mostly some of these are introduced. We have 2 there which are introduced by climate change, warming seas. So they are kind of quite the south coast again, you would kind of expect is where they are mostly appearing. And we also have this list. This is where we kind of expect, these are the species we think will be moving northwards and expanding on the left hand of that column. And these are the northern species which like colder water, which will probably be going northward and kind of heading more to the more Arctic regions. And this is using mostly it's the National Biodiversity Network. So these are all sightings of these species around the whole of the UK coast. And I think also that one, the small-eyed ray, this is fish base, which is, these are projections. These are where they think this particular species will have extended to will cover all of the Irish UK waters by 2100. And whereas it is now, it's only kind of found on the south coast. So this has given us a bit of an idea about what the marine species are doing. We can, from those potential biomarker species, we can look at, they are clustering, seem to be clustering about 5 areas. So these could be taken forward with the Marine Conservation Society to ask them, they're kindly with their volunteers to do more focus their repeat surveys on these clusters to kind of keep an idea of, what's really happening. So that's, for the Welsh coast. And just to see, there are some huge gaps in knowledge. And I know we're all very concerned with the marine wood-boring species like the gribble and the shipworm. But really, we have so little data from which to really draw. And I was a bit disappointed, I suppose, really, but we have so very little data about these species. What we do know is that we have a warmer water species which is coming in, which is replacing Limora lignorum, the gribble. That's kind of in our southwest Wales at the moment. But so a lot of these, for the teredo, the shipworm, a lot of these sightings are from the 1950s and 1960s. So we have a huge gap in our knowledge base to understand more what is happening with them. But I think I suppose we can draw trends on what is happening with the rest of the marine species. So that's it. I've kind of galloped through, condensed a lot, and I hope I haven't confused you too greatly, but just leave you with, this is one of our little sites, another photographic survey. It's one of our traditional fishing boats, an oyster skiff from Mumbles Bay near Swansea. And I put my contact details there. Thank you very much indeed.
Thank you so much, Diane. I was actually active for your email, for contacting you. I really, really enjoy your presentation, so thank you so much. We have 5 minutes to final question, so I'm going to open the floor, but first I'm going to read the question that Bella Romain asked us through the Zoom chat. She said that, are you looking at any other heritage assets, or it is only related with wrecks? And also, I have some photos from Carmarthen Bay, which I think match UC squares. Happy to send them over if you share your email, which you already do. So
I think if to look at, I know we've done some presentations, some fantastic coastal archaeology today. I had to make a decision really, because to look at the shipwrecks, and I think that was the driver from that, came from that Welsh historic environment sector. And the consciousness that, still offshore from the Welsh coast, so many of our sites, we have our baseline information about them comes from Royal Naval surveys from the 1970s and possibly into the 1980s. Bangor University is doing a big program of multi-beam with their research vessels as they whiz around and do various other things. As they turn it on as they go over the top of a wreck. But I think this is where we kind of felt, well, I felt that probably my effort should be focused on the kind of the shipwreck side. But yes, you're right. There we have fish traps, lovely selections of fish trap. We have something like 70 exposures of intertidal peats, which are really fascinating, which are really under-researched. And there's a lot of coastal structures, piers, and some of the things that Luque showed as well. There is, the early types of harbours and landing places, which are all, that's sea level rise, I suppose. I probably would, going to the School of Ocean Sciences, I probably plump for the more sciencey thing, because I thought I might. It's more difficult for me, but there is such a selection of knowledge there to kind of help with that more science side. That's kind of where I focused on. Does that help? Yeah.
Thank you so much. I don't know, we have space for one more question.
I have
meanwhile, terrific.
Sorry. Was it someone else? Okay, I can have the question. So I was wondering if you, I mean, you have amazing data, and all of the work we've done there in Wales is like really amazing. I was wondering if you know if anything similar is done for the rest of the UK, or if you plan to share this, like all these frameworks that you have already collected with, like, let's say Scotland and England, because it's really impressive, all of the studies you've done.
Yeah, well, thank you. It's some heartache and some headache at times, but yeah, I think so. I mean, we are Wales. We are part of this network, and certainly that I worked for the Royal Commission before I stepped off to do this, and certainly the Royal Commission is very much linked into Cadw is our heritage agency in Wales. Historic England, there's our colleagues in there, so yes, they will. I'm in the process of writing up, so the PhD itself will be shared, and then I think then it's to look to perhaps talk to the Royal Commission and Cadw about whether they want to do a synopsis of this. The group that produces the Welsh Heritage Sector Climate Change and Mitigation Plan, basically that's due. There's a new set of agendas, a new set of priorities will probably come in next year. So this, a synopsis of this could, become part of that document as well. So yeah, it will go in the public domain. I'm still writing.
Perfect. That's amazing.
Yeah. Okay.
That's great. Thank you.
Yeah. And of course, yes, you have it today. So anyone want to share this this presentation to show to others and colleagues, you're very, very welcome.
Thank you so much.
Well, thank you all, of course. That was the second session related with climate change impacts on maritime archaeological sites. Now we have a lunch break until 1 p.m. So before that, I would like to also once again thanks to Katarina and Victoria for this fantastic space, for let me speak a little bit in this small but fantastic place from the NGO Colombia Amphibia. We are very happy to help to do some things for this space. And I'm going to ask all of the participants, who I hope that you can join us to the rest of the day, for and prepare some discussion comments for the final discussion, which is going to be after 3:25 p.m. The questions are related with what is the future of archaeology within the climate emergency, what is required to successfully manage and safeguard maritime heritage, and what support do early career research or the field need. So I think that will be for this session. Katerina, you let me know. Victoria, well, once again, thank you so much. I hope we can see each other once again in a couple of minutes. And well, all the best from Colombia. Thank you so much.
Thank you so much for sharing, and everyone, thank you for participating so far. Now we'll have our lunch break. We will resume at 1 o'clock for session 3. And then, as Jesus said, we're going to have a discussion at the end. So there we can discuss even more all of our perspectives that we have been discussing already. So thanks.